All right, y'all. So we are going to start with part 1 of the final exam review, and part 1 is graphing and solving radicals. So very first question asks us to describe all the transformations for these 4 equations. So starting with A, I'm going to highlight as I go. So this first one right here out front means that we're going to reflect across the x-axis. Okay, next we have this underneath the radical. Remember, x's lie, so it's going to go the opposite way. So we have that we are going right 3. And then on the very end, let me get a new color. On the very end, we have this 6, and that is going to tell us we're going up 6. So going over to B. Okay, so when we look at B, the first thing we need to notice is this negative right here, okay? If you remember from a while back, we have to actually take out this negative. So it's going to be 6 to the square root of a negative, because we're going to take that negative out, and we're going to have x minus 2 left under that radical. And we can't forget that 5. So this negative, when it's underneath the radical, is going to tell us that we have a reflection across the y-axis. Okay, the 6 out front, we're going to have a vertical stretch by 6. Remember, if it's greater than 1, we're going to be stretching. If it's between 0 and 1, we're going to be compressing. So here we have a stretch. Next, we have x minus 2. Remember, x's lie. X is under the radical, so we're going to be going to the right 2. And then last but not least, we have this minus 5 on the outside, so we know that this is going to be down 5. Okay, moving on to C. Okay, here we have a cubed root, but that doesn't change any of our transformations. So the first one we have is this 1/4, and since it's on the outside of the radical, it's going to be a vertical compression by 1/4. Now we have underneath the radical this 5. Now, since it's under the radical, that has to do with the x's. Remember, x's lie. So this is going to be a horizontal either compression or stretch. But remember, if we have the 5, we're going to flip it, and it's actually going to become 1/5. 1/5 is going to be a compression. So you have a horizontal compression by 1/5. And those are the only 2 transformations for that equation. So moving on to D, we have this negative out front, which means we're going to have a reflection. And since it's on the outside of the radical, it's going to be across the x-axis. And then our next reflection, we have that 1/3 under the radical again. So remember, x's lie. So we're going to flip this, so it's going to be a horizontal. And then we know we're flipping it, so it's going to be 3, and 3 means that we're going to be stretching. Okay, so those are your transformations. So moving on to the next part, we have graphing. Okay, so I'm going to go through the way that we learned to graph points in the very beginning, but I will also show you how you can use Desmos to plug these in to also look at the graph to find the domain and range of the graph. So if we're thinking back, when we have radical, we have just a square root function. What are the points that are easy to plug in to this equation? If we have our xy table, we know if we put in 0, 1, 4, and 9 into a normal just y equals square root of x, we're going to get the output of 0, 1, 2, and 3. So we're going to use these points and transform these points to match our new equation. So our new points are going to be x. Remember, x is lie, so the things that are going to change the x are under the radical. So we have x plus 3 here, which means when we put it in our table, it's going to be x minus 3. And then everything else is going to affect the y. So we have 2y minus 4, but none of that changes. So we're going to take all of these x values right here and plug them into this x minus 3 to get our answers. And our answers are going to go right here. So these values are going to transform to be -3, -2, 1, and 6. Okay, and then same thing, we're going to take these y values and we're going to plug it in right here for y, and we're going to get -4, -2, 0, and 2. So next, all we have to do is plot these points. So if we plot these points, we're going to be plotting the ones here in pink. So we're going to have -3, -4, -2, -2, 1, 0, and 6, 2. Remember, we're not going past this point, okay? We're not doing this. This is a no, okay? We're going to start at that point, and our graph is going to come up and over, and we're going to have an arrow on it. Okay, so that way you can see that if we're looking at domain and range, remember, domain is the x values, and range is the y values. So we're looking from left to right for the domain. So our domain is going to start at -3 with a bracket, and it's going to go all the way to infinity. And then our range, we're going to look from the bottom of the graph, the most negative of the graph, all the way to the most positive part of the graph. So we're going to go from the bottom to the top. So starting at the bottom, our first y value is -4, and it's going to go to infinity as well. Okay, so I know I mentioned earlier putting this into Desmos, so I have my Desmos app open. So I'm going to switch over to that. Where did it go? There we go. So if you type this into Desmos, 2 square root of x plus 3, and then you can arrow over -4. You have the same exact graph that we just graphed on our own. Okay, so either way, you can use that to look at the domain and range. All right, so moving forward, graphing this one, the same thing. You can graph it using the points that we taught you. You could use it doing the graphing calculator, or you can use Desmos. At this point, use your resources, whatever you have, to help you be successful. So I'm going to go through the way that we taught you in the beginning. So we're still working with a square root function. So we're going to use 0, 1, 4, and 9, which will give us the outputs of 0, 1, 2, and 3. We're going to shift our points here. Remember, x is lie, so instead of x minus 1, we're going to write x plus 1. And then we have to be careful here because there's a negative out front. So our y is going to be -y plus 5. And so our new points are going to become 1, 2, 5, and 10. And our new y values are 5, 4, 3, and 2. And again, I plugged all these values in here for x and got those answers. And then I plugged these y values in here and got those y values. Okay, so this point now, go ahead and plot your points. 1, 5, 2, 4, 5, 3, and 10, 2. Okay, so this one is reflected because of the negative, and you can tell that when you plot these points. So we're starting here, and we're going this way. Okay, so here when we do domain and range, we have to be really careful. So domain, we start leftmost. Our leftmost x value that is included is 1, and we go to infinity. However, when we have the range, we need to look at where our graph is going. Since we know that our graph is going to go this way and keep going down and down and down, we're going to start our range at negative infinity, and then we know that our upmost y value, our highest y value, is going to be 5. So that's our range. Okay, so for 4, we're just finding the domain and range of graphs. Oh, sorry, this should be a bracket. Sorry about that. So, sorry, moving on to domain and range of number 4. This here we have a cubed root graph, okay? When you see a graph that goes like this, we know it's cubed root because it keeps going on and on in both directions. Anytime you see this and you're finding the domain and range of a cubed root, it's always going to be negative infinity to positive infinity. Okay, there's nowhere on this graph where we stop, okay? It's going to go both ways, on and on and on. All right, so this last one here, this one, you remember our normal graph looks like this, okay? So this one's reflected a couple times. So the domain for this, we start at the leftmost side, and we're going to work our way this way. Well, we have all the x values going this direction, so we're going to start at negative infinity, and our last x value is at negative 1 with a bracket. And our range, we're going to start at the bottom and work our way up. Okay, so our range starts at negative infinity, and it goes until negative 2 with a bracket. Okay, so that's a quick review over the transformations, how to graph and find domain and range. Next, we have a graph of 4 equations that you need to match, you have 4 graphs that you need to match with 4 equations. So everyone likes to do this a little bit differently. One way that you could do it, I'm not going to show, but you could take each of these and plug these into Desmos and see what the graph looks like and match it that way. The way that I'm going to show you how to do it is to just take one and focus on one at a time and actually build that equation based off the graph. So I'm going to start with A. Okay, A is the green line here. Let's first remember what our graph normally looks like. So if we have a square root, we know that our x, y values are 0, 1, 4, and 9 with the corresponding y values of 0, 1, 2, 3. So I'm going to use purple since purple's not on there. So we have 0, 0, 1, 1, 4, 2, and then 9, 3 is not on the graph. But this is what our graph looks like to begin with. So we're trying to see what transformations have happened to this purple line that make up the green line. So if I'm going to look at just A, we know that there was a reflection. Well, before I get ahead of myself, let me draw the radical. Okay, so we know that there's a reflection. This reflection occurred across the x-axis, which means we're going to have a negative out in front of our radical. Okay, also we know that this graph was over 1, 2, 3, 4 and up 1. So we're going to have a plus 1 on the outside for the up 1, and then we're going to the left 4, which means in our equation it's going to look like x plus 4 because x is y. Okay, so that's the new equation for A. So which one does this match up to? This looks like 3. So we know that 3 is going to be A. Okay, so for B, we also have a reflection, but where is this reflection going to be? This reflection is going to be on the inside because it's reflecting over the y-axis right here. So we're going to have the negative on the inside. Our graph is moved to the right 4, which is going to look like x minus 4. And then we're moving up 1, so it's going to be plus 1. So this one is going to be number 1. And then we have C, which is orangey yellow. So for C, okay, I'm going to start with my radical again. We know that we're reflecting over the x-axis for sure, but also we're reflecting over the y-axis. That means we're going to have 2 negatives. We're going to have a negative on the outside and a negative on the inside. For C, we're also moving to the right 4 again, and this time we're moving down 1. So that equation corresponds with 4. And then process of elimination, you guys are very good at. So you know that 2 is probably D, but let's be sure. So for D, I'm going to write over to the side. We have the square root. Okay, we're not reflecting. Okay, so there's going to be no negatives, but we are moving down 1, and we're moving to the left 4. So it's going to be x plus 4 minus 1, and that is the equation that we're given. All right, so next we're going to be solving. So when we're solving, biggest thing, you have to make sure that you do not have any extraneous solutions. Okay, I know this is a little while back, so you're going to have to remember all those rules of solving and extraneous solutions and what it means to be an extraneous solution. So let's start working through these problems. Remember, to solve, we want to get the radical isolated, which means we want just the square root of x minus 5 by itself. But we have the 4 in front and we have the 2 in front. So we have to use reverse PEMDAS, reverse order of operations, to try to solve this. So the first thing we're going to do here is we're going to subtract the 4. So if I subtract 4, I'm going to have 2 square root x minus 5 equals negative 14. My next step is to divide by 2 because that radical is still not isolated. So if we divide by 2, we're going to have the square root of x minus 5 equals negative 7. So now the radical is finally isolated, so we can square both sides, because what you do to one side, you have to do to the other. Square both sides. We're going to have x minus 5 equals 49, and then add that 5 over. Running out of room. So we get that x equals 54. Okay, but we're not done. We have to check. We have to check to see if this is a real solution or if it's an extraneous solution. So you need to take 54 and you're going to plug it in for this x value. So if I plug in 54 for x, I'm going to get what? We're going to see that these two do not equal each other. Okay, so we're going to say that there is no solution. Okay, so moving on to B. Again, here we want to isolate this cubed root. So we're going to subtract 1 to start. We're going to have negative 4 times the cubed root of x plus 2 equals 12. Next, we're going to divide by that negative 4 so we can get the radical isolated. We're going to have the cubed root of x plus 2 equals negative 3. Okay, at this point we want to get rid of the cubed root, so we have to cube both sides. Okay, be very careful here. When you're cubing a negative, it'll be a negative times a negative times a negative, which means the result will be a negative. So cube both sides, we're going to get x plus 2 equals negative 27. Next step is going to be to subtract 2 from both sides to get x by itself. X equals negative 29. Okay, and then if we check this, you can plug it in your calculator. If we do 1 minus 4 times the cube root of negative 29 plus 2, what does that equal? Well, we're going to have the cube root of negative 27, which is going to be negative 3. Negative 3 times, let me write it out for you. Okay, this is going to be 1 plus 12, which equals 13, and that is equal to 13, which is what we're looking for. So we know that this here is a proper solution to this equation. Okay, so for C, we have a radical on both sides, so we don't want to divide by 4 here because that would make things confusing. But what we want to do is we want to go ahead and just square both sides. However, when we square both sides, we also have to square this 4. So when we do that, we're going to get 14x minus 40 equals 16 times x minus 2. Very important, we have to distribute this 16 to both of these. So we're going to have 14x minus 40 equals 16x minus 32. Subtract 14x. Negative 40 equals, 2x minus 32. And then if we add 32 over, you guys should be pros at this by now. We're going to have negative 8 equals 2x, which means that x is going to equal negative 4. Okay, but let's see what happens if we plug negative 4 in. So if I take, let me rewrite it. If I take negative 4 and plug it in here, okay, I'm going to get 14 times negative 4, negative 56 plus, so we're going to get square root of negative 96 which you cannot take a square root of a negative, so you already know that that's not going to be equal. But just in case you want to try the other side as well, you would have the square root of negative 4 minus 2, and again, you can't take the square root of a negative, so this one is going to be no solution. Okay, and last but not least, here we have a radical on one side but not the other side, so we're going to do what we normally do. Get rid of the radical, we have to square it. So square both sides. However, when we square this side, remember this is not the same as x squared plus 4. Okay, you have to multiply x minus 2 times x minus 2. And that's going to give you x squared minus 4x plus 4. So you're going to put that back in over here. So we're going to have 4x plus 24 equals x squared minus 4x plus 4. And then at this point, we want to move everything to one side, and we're going to have to factor. So we're going to subtract the 4x and the 24. So we're going to end up getting 0 equals x squared minus 8x minus 20. Okay, now you're going to have to remember how to factor. So a times c, when we factor this, we're going to get x minus 10 and x plus 2. Set those equal to 0. We're going to get x equals 10 and x equals negative 2. So you have to plug both of these back in to your equation. So you want to see, does 4 times 10 plus 24 equal 10 minus 2? Yes, it does. So that is a solution. Okay, let's try the next one. 4 times negative 2 plus 24. Does that equal negative 2 minus 2? Nope, that does not. So this is not a solution. So you only have one solution for that one. All right, now everyone's favorite, word problems. So the number of people, y. So y is the number of people. Okay, that's important. Arrive at Winterfest, and we have this equation right here. And we are also told that x is number of minutes. Okay, so the first question is finding the number of people after exactly 45 minutes. Okay, so we're going to need to use our equation. Y equals 11 times the square root of 5x plus 90. Now, what do we need to find? We want to find the number of people. So the number of people is y. So we're solving for y, and we have an x value here. So we're going to put in 45 minutes for x. So we're going to have 11 times 5, the square root of 5 times 45 plus 90, which if you put in your calculator is going to be 255 people. And then this next one is asking how many minutes is our purple, it's our x, will Winterfest have been opened if we have 200 people. Okay, so people is our pink, it's our y. So this time we're going to be solving for x. So we're going to plug in 200 for our y. So we're going to have 200 equals 11 times the square root of 5x plus 90. And then here we just have to solve for x. So first step, backwards order operation, subtract the 90. We have 110 equals 11 times the square root of 5x. Next step, divide by 11. 110 divided by 11 is 10. So we're going to move over here. We have 10 equals the square root of 5x. Next step, to try to get x by itself, you're going to square both sides. So we're going to have 100 equals 5x. And then last but not least, divide by 5. And we're going to get x equals 20 minutes. All right, and that is the completion of part 1 of the